questions. First is solve x plus 1 dy upon dx is equals to 2xy. In these types of equations, the two variables are together, x and y. First we have to separate these variables and then solve the differential equation. X plus 1 dy is equals to 2x upon x plus 1 dx. Now terms of y and x are separate. Now we will integrate both sides. Integral of 1 upon y is log y. 2 is constant. Add and subtract 1 here. X plus 1 upon x plus 1 minus 1 upon x plus 1. Integral of 1 is x. Integral of 1 upon x plus 1 is log of x plus 1 plus c. Log of x plus 1 plus c. Now log y is equals to 2x minus log of x plus 1 plus c. Log y is equals to 2x minus log x plus 1 plus c. Second is solve cos of x 1 plus cos y dy. Cos of x 1 plus cos y dx minus sin y into 1 plus sin x dx is equals to 0. Cos of x into 1 plus cos y dy minus sin y into 1 plus sin x dy is equals to 0. Here we have dx and dy. Now first we separate the terms, separate the variables. Dx is equals to sin y 1 plus sin x dy. Here we have the terms of dx, cos x dx upon 1 plus sin x, sin y dy upon 1 plus cos y. Now integrate both sides. Now derivative of sin x is cos x and derivative of 1 is 0. So this is of the form f dash x upon f of x, and integral of f dash x upon f of x is log of f of x. Now derivative of 1 is 0, derivative of cos is minus sign, so we multiply and divide here by negative sign. Log 1 plus sin x is equals to minus log 1 plus cos of y plus c. Log 1 plus sin x plus log 1 plus cos y is equals to c. Log a plus log b, we can write it as log a into b. Instead of c, all the terms are of log, so we can write here log c also. Log of a into b is equals to log c. So what we get here? 1 plus sin x into 1 plus cos y is equals to c. 1 plus sin x into 1 plus cos y is equals square x tan y dx plus sec square y tan x dy is equals to 0. Sec square x tan y dx is equals to minus sec square y tan x dy. Now here we have dx, so sec square x dx upon tan x is equals to minus sec square y dy upon tan y. Now derivative of tan x is sec square x. This is again of the form f dash x upon fx. Integral of this is equals to log of fx. So log of tan x is equals to minus log of tan y plus constant log c. Log of tan x plus log of tan y is equals to log c. Log a plus log b, we can write it as log a into b. So tan x into tan y is equals to c. Tan x into tan y is equals to c. Next is Ex into square root of 1 minus y square dx plus y upon x dy is equals to 0. Ex into 1 minus y square dx. Here we have the terms of x, ex, dx into x minus y upon 1 minus y square dy. Here we use elate first, integral of second minus derivative of first, integral of second. Here we complete the derivative. Derivative of 1 is 0. Minus y square is minus 2y. So multiply and divide here by 2. Minus 1 by 2. 1 by 2 minus 2y. 1 minus y square power minus 1 by 2. Now here we have the formula. Integral of f dash x into f of x power n. What is the integral of this? Is equals to f of x power n plus 1 upon n plus 1. X, ex, derivative of x is 1. Integral of ex is ex. So integral of ex dx 1 by 2. This is f dash x and f of x power n. So f of x power n plus 1 minus half plus 1 is 1 by 2 plus c. X ex minus ex is equals to square root of 1 minus y square plus c. Next is question number 5. Write down question 5. Solve the differential equation 1 plus e 2x dy plus 1 plus y square ex dx is equals to 0, given that when x is 0, y is equals to 1. First separate the variables. 1 plus e 2x dy is tan inverse y minus tan inverse ex plus c. When x is 0, y is 1. X is 0, something power 0 is 1. Tan inverse 1 is pi by 4. Tan inverse 1 is pi by 4. Or we can write it as e power x. So c is equals to e power, here we have to put value of x as 0, something power 0 is 1. Tan inverse 1 is pi by 4. So c is pi by 4 plus pi by 4, 2 pi by 4, that is pi by 2. Now put the value of c in the given equation. Tan inverse y plus tan inverse ex is equals to pi by 2. Tan inverse y plus tan inverse ex is equals to pi by 2. Now we know there is one identity, tan inverse x plus cot inverse x is equals to pi by 2. So we can write it as tan inverse y is equals to pi by 2 minus tan inverse ex is equals to cot inverse ex tan inverse x plus cot inverse x is equals to pi by 2. Note it down. Next question is question number 6. Solve the differential equation 1 plus y square into 1 plus log of x dx plus x dy is equals to 0, given that when x is 1 then y is also 1. Given that when x is 1, y is also 1. First separate the variables. 1 plus y square, 1 plus log x dx is equals to minus x dy. 1 plus log of x upon x dx, dy upon 1 plus y square. Integrate both sides. Here put 1 plus log of x as t. Derivative of 1 is 0. Log x is 1 upon x. So 1 upon x dx is equals to dt. 1 plus log x is t. T dt. Integral of 1 upon x square plus a square is 1 upon a tan inverse x upon a. Integral of t, what is t here? 1 plus log x, 1 plus log x whole square by 2 minus tan inverse y plus c. When x is 1 then y is 1, log of 1 is 0 minus tan inverse 1. Tan has value 1 for pi by 4. Log 1 is 0, so 1 by 2 minus pi by 4 plus c. So we get the value of c as 1 by 2 plus pi by 4. Put this value 1 plus log x whole square by 2 is equals to minus tan inverse y plus 1 by 2 plus pi by 4. From here we get tan inverse y is equals to 1 by 2 plus pi by 4 The next is question number 7. Solve the differential equation x into 1 plus y square dx minus y into 1 plus x square dy is equals to 0, given that y is equals to 0 when x is equals to 1. First separate the variables. X 1 plus y square dx is equals to y 1 plus x square dy. X upon x square plus 1 dx. Y dy upon y square plus 1. Derivative of x square is 2x, so multiply and divide by 2 here, same on the right hand side. Now we have the formula integral of f dash x upon f of x is log of fx 1 by 2 log of x square plus 1 is equals to 1 by 2 log of y square plus 1 plus c. 1 by 2 will be cancelled from both sides. Log of x square plus 1 minus log of y square plus 1 plus c. Log of a minus log b is equals to log a upon b. Or we can take the constant of integration as log of c also. So here we get x square plus 1 upon y square plus 1 is equals to c. Now when x is 1, then y is 0. So we get the value of c as 2. So x square plus 1 is equals to 2 into y square plus 1. X square plus 1 is equals to 2 into y square plus 1. Now the next question, number 8. Solve the differential equation dy upon dx is equals to 1 plus x plus y plus xy. From these two terms, take y common. 1 plus x is common factor, so it becomes 1 plus x into 1 plus y. Dy upon y plus 1 x plus 1 dx. Integrate both sides. Integral of 1 upon x is log of x, so log of y plus 1 here. Integral of x, integral of 1 plus c. Log y plus 1 is equals to x square by 2 plus x plus c. Next is solve the differential equation y minus x dy upon dx. Y minus x dy upon dx is equals to a into y square plus dy upon dx. Y minus x dy upon dx is equals to ay square plus a dy upon dx. Y minus ay square is equals to a plus x dy upon dx. So dx upon a plus x is equals to dy upon y